Basics of routing. Hello everyone, today we will go ahead and start routing. Now routing is actually to route packets from one location to another location. That is the general definition to routing. Now from the perspective of the network layer in the OSI reference model, we have two types of protocols: routed protocols and routing protocols. Now what are routed protocols? IPv4, IPv6, ISO, AppleTalk, Banyan 1, etc. These are actually routed protocols. These are actually logical addresses which has two portions, a network portion and a host portion, the name of the location and the house number. These are actually carried by the routing protocols from one location to another location. Now routing protocols, we have different flavors of them, different types of them. REP is there, Eigrp is there, OSPF is there, ISIS, BGP, OMP, etc. These are actually routing protocols. Now analogically, if I give you an example, would be that I as a human being am an IPv4 packet. Let's say I am an IP packet, and if I want to go from location A to location B, there needs to be some sort of a carrier that should carry me from location A to location B. Now what could be the carrier? Like analogically, I would say a car or a bike or an airplane or some sort of a carrier would be the routing protocol that would carry me from location A to location B. And we have different types of them. Some could be used for, let's say, used in small environments. Some may be used in big environments. Every one of them has their own pros and cons, and everyone has its own features and characteristics. Now we can do routing in one of two main methods. We can do it statically and we can do it dynamically. Now statically is when we manually as a human educate the routers or firewalls or whatever devices they are to route packets from one location to another location. We as a human would administratively do that. Let's say in this topology, in this very simple topology, I have, let's say, two devices, device A and device B. They could be routers once again, or firewalls, or whatever type of devices they are. And I have three networks. This is, let's say, assuming that this is network 1 and this is network 2. And let's say this could be another one, which would be, let's say, network X. Now router A is directly connected to network 1, to this network, and A is also connected to network X. So router A has information about these two networks only, network X and network 1. So router A has no information and no knowledge of network 2. So we as a human would manually, administratively educate router A to forward packets to B for this network. Similarly, we need to educate router B to forward packets to A for this network. This process is done administratively. Now static routing is only good for small environments. If you have 2, 3, 4, 5 sites and you have a couple of networks, then static routing is good there. But if you have complex environment or big environment, multiple sites, large environment, then in that case, the other option is dynamic routing. Now in dynamic routing, an algorithm is run by any one of these routing protocols at the back end to find a closest path to reach a destination. Let's say in this topology here, I have three routers now, router A, B and C, and everyone has its own network, network X, Y and Z. Now router A will find the closest path to reach network via B. Now what if we use static routing here in this type of an environment or topology? Now in that case, we as an admin would have to manually educate router A to forward packet to B for network Y. Now the drawback here would be that what if this link goes down? Router A will not know that there is another route to reach network, or path actually to reach network via C. So that is one drawback in static routing. But if you use dynamic routing here, so A will find the closest path to reach network Y via B But if in case it goes down, the dynamic routing protocol would automatically fail over to C to reach network Y. And this is done automatically. That's one beauty. And the other one is that it reduces administrative overhead. And it's good for manageability as well. It gives you ease of management. Instead of, if let's say, if you are having hundreds of sites and thousands or hundreds of networks and you use static routing, in that case, you would have to statically educate every device to route packets from one location to another, to another, to another. So that would be administrative, administrative overhead. Now there are two categories of dynamic routing protocols: distance vector and link state. Now we have RIP as a distance vector routing protocol, where RIP uses distance or specifically hop count as a delimiter to find the closest path to reach a network. Let's say if you are using RIP in this environment, now for A to reach network Y, it would have two paths, one via B and the other one via C. So if it say, if the router A would say, if I go via this, it would basically take me one hop away. It's one hop, one handoff point to reach network Y. If I go via this path, I would have to go one hop and two hop. So RIP would consider this being the closest path to reach network Y. Now the other one we have is link state routing protocol, and OSPF is a link state type, and ISI is intermediate system to intermediate system. This is the OSI flavor, and this is open standard. Both are actually open standard, but this is for initially it was created for ISO addressing, the International Standardization of Organization, which is 128-bit. However, we can use IPv4 or IPv6 as well on this. We'll come back to each one of them one by one, but for right now, I'm just giving you a quick overview here. So OSPF and ISIs, they would check the or consider the state of the link as a delimiter to find the closest path to reach a specific destination. So let's say in case of RIP, if I had this one being 128 kbps link, and if I had 1 gig links here, 1 gig here, 1 gig here, so RIP would still consider this being the shortest, which is not a good or an optimum path. It's not a good path then in that situation. We have 1 gig links here, and this is actually a 128k link. So OSPF or link state routing protocols or ISIs, they would consider this being the optimum path to reach network Y. Even though it's 2 hops away, but it would say this path is now good to reach network Y. So let me clear the screen. Let me completely clear it. So the next one we have is Eigrp. Now Eigrp initially was designed by Cisco, but prior to Eigrp, they had something called Eigrp, Interior Gateway Routing Protocol, and then they enhanced it. So there were some drawbacks of broadcasting and no authentication support and no VLSM, etc. Then they enhanced it to Eigrp. Eigrp is actually a hybrid protocol. We would come back to all of them one by one. However, I'm just once again giving you a quick overview right now. So Eigrp is a hybrid routing protocol, and it uses a compound metric. The other one we have here is BGP. BGP is these are actually used within an IaaS or autonomous system inside a company, you can say, or inside an infrastructure. However, you can use BGP between different autonomous systems. And the only EGP, these are called IGP protocols, interior gateway protocols. These are called IGP protocols, all of them. These are called IGP protocols. And this one is called EGP protocol. Initially, EGP was by its own self a protocol. Then they converted it to a category and designed BGP as a protocol. And we have BGP v4 nowadays. So BGP is the only protocol that is in EGP category. Now, because of the BGP, we are having internet. If you don't have BGP, if we remove BGP as a protocol from the internet, we would not have internet. Now, BGP uses different attributes. It's actually a path vector. They call it a path vector protocol. So it's actually a path vector protocol because it uses different attributes. So for instance, it's actually using weight, local preference, med, AS path, BGP community, origin ID, etc. We'll come back to all of them one by one, but for right now just only understand that it is a path vector protocol. And we have OMP, overlay management protocol, which initially was designed and made by Viptela for SD-WAN, and later on Viptela was acquired by Cisco. So it's actually a routing protocol that's used between vSmart and vEdges. So we will come back to all of them one by one. So I guess that's the simple routing definition. So let's go ahead and start with RIP.